Welcome students to our Student Camps 2022 PEP preparation series. Today we are continuing our look on science curriculum-based test. Alright, so today before we get into our session, we want to just remind ourselves of a couple of things. When you are looking at your exam paper, we want you to remember to read the question carefully, and this is to ensure that you're clear as to what the question is asking you to do. And in most cases, there are some key instructions in the question, so you want to look for those as well. Okay, let's look at our first question. So today we're looking at an investigation of how light interacts with a transparent bottle. So we're given a diagram that we must interpret, and we're asked which statement is incorrect. So please note that this question, as mentioned, we're looking for the instructions, is asking us for the statement that is incorrect. And so we have to look for what is not suitable for the diagram presented. All right, so our first task then is to look a bit closely at the diagram. So let's look at the diagram a bit further. The diagram has a bottle, right? Notice we're shining light from a flashlight, and we're noting the path that the light travels. So the path that it travels is shown by a series of arrows. So it starts from 1, right? The light path continues to 2. At 3, we need to identify what is happening to that light ray. All right, if it continues on from 1 to 2 and continues to 4, passes through the bottle, notice what happens to the light ray as well. So by now, you should be able to identify where the light ray is being reflected, where it is being bent, that is refracted, and of course, as it passes through the bottle from 4 to 5, we note what is happening to the ray. So let's go back to the question. So the question says, which statement is incorrect? So we're looking at the pathway of the light. So when it travels from 1, 2, and 3, what process is happening there? We could say that the light is being reflected, right? Good. And if we traveled from 1, 2, and 4, right, we could say that the light is actually, the ray is being bent, so it is refracted. So which statement is incorrect? Is it that pathway 1, 2, and 4 shows refraction? Is that incorrect? No, that is actually correct. Is it that the bottle allows light rays to pass through? Well, that is true, so it is not incorrect. Let's look at B. Pathway 1, 2, and 3 shows reflection. Is that correct? That is correct. So which statement then is incorrect? The answer then must be A, because A is suggesting that pathways 1, 2, and 3 shows refraction when we can clearly see that it actually shows reflection. So that would be our answer. All right, let's look at our second question. So here we're given a table with some results from an investigation where a student dropped some metal discs, and notice they are of different diameters, and they're recording the pitch of the sound made by indicating whether it was high pitch, medium pitch, or low pitch. So again, we want to look more closely at our table, because once you're given information, you must be able to analyze that information first of all. So let's look closely at our table. All right, so we have our metal disc of different diameters. That's indicated in the first column, and we're looking here for trends. So in the first column, the size of our disc, that is the diameter, is doing what? More or less changing, yes? And the height that we're dropping them from is the same. Of course, when we think of fair test, we know why we're keeping the same height. All right, so at 3 centimeters diameter, the pitch is recorded as low, yes? At 10, the pitch is recorded as medium. What happens at 5 centimeters? Yes, we get a low pitch. So it seems as if when the diameter is smaller, the pitch would be low, right? As we increase that diameter to 14, pitch is medium, and to 18, the pitch is high. So we can more or less determine that the trend is for the lower values, diameters of lower values, the pitch is low. Those in the middle, the pitch is medium, and those higher, right, 18 it would record a high pitch. All right, so let's now go back to the question. So the question is asking us to find a statement that best supports the prediction from the student. And what was that prediction? That a metal disc with a diameter of 4 centimeters would produce a sound with a low pitch. So which statement then best supports that prediction? Diameters of 5 cm produce a sound with a low pitch. Diameters 3 to 5 cm produce a sound with a low pitch. Diameters below 18 centimeters produce sounds of different pitches. And diameters below 18 centimeters produce sounds with a high pitch. So we can cross out the statements that are obviously incorrect, right? So below 18 centimeters producing sounds of different pitches, and diameters below 18 produce sounds with a high pitch. So from what we have seen, it doesn't seem as if diameters below 18 produce high pitches, right? So which is the best? So we're looking for the best statement, right? And the best statement would be that diameters between 3 and 5 will produce a low pitch. And so they could predict that a 4 centimeter diameter would also give us a low pitch. Remember, in that question, you're looking for the best statement. Okay, let's look at this third question. Again, we're in the unit on light, and we're looking at how light interacts with objects. So here, we're given a table where we're changing the distance of a light source, which is a flashlight, and we're looking to see how it produces an image on the area on the wall. And so we're looking at how the area of light on the wall changes. So the question is saying which is not a pattern. So remember, looking for instructions in our questions to see what it's asking us to do. So we're looking for what is not a pattern. So again, as we have demonstrated, we want to look closely at the information given in the table. All right, so look at this and tell me what you see. Can you see any patterns? All right, so let's check it out. So what is happening to the distance of the flashlight? Okay, so we can see that the distance of the flashlight from the wall is steadily increasing, right? So it's increasing. And then what is happening to the area of light on the wall? As the distance changes, the area of light also increases, right? So as we change the distance, the area of light changes, and that is increasing. So we're looking for a statement which is not a pattern in the table, all right? So let's look at these statements. As the distance of the light of the flashlight increases, the area of light increases. Do we see that pattern? Yes, we saw that pattern. So that would not be our answer because we're looking for one that is not a pattern. As the distance of the flashlight decreases, the area of light decreases. Yes, because if we should go in the reverse order, we would see that pattern. The area of light on the wall is twice the distance of the flashlight from the wall. So do your calculations, yes? When the area of light is 6, the distance is 3. When the area of light is 16, the distance is 8. Is that twice that value? Yes, it is. So the last statement says, as the distance of the flashlight increases, the area of the light decreases. Did we see that pattern in the table? No, we didn't. What we saw was as the distance increased, the area of light increased. So D would then be our answer. Good. I hope you are seeing that in many of these questions, we need to do some analysis before we answer our question. All right, here is our next item. Again, we're looking at light, and we're told that when the sun's rays pass through a magnifying glass, we can focus them on a single spot. I don't know if you have ever tried this, but this is a way to make fire. Yes, you can make fire, students. All right, so if you get a magnifying glass or a hand lens and you focus that on a spot, right? So the sun's rays are passing through the glass, and each time, if we look at those rays, right, they're coming straight, but when they reach to that focal point, that ray would now be bent. So the question is, which property of light is demonstrated by this activity? Is it that light can travel in a straight line? Now, we know that that is a part of the property of light, but is that the property being shown in this particular diagram? No. Is it that light can be refracted? What is refraction again? The bending of light. Are the light rays being bent? Yes, they are. Right. And so basically the property that is being demonstrated, and so we have to look at the question, is that the light rays can be bent, which is B. All right, so now we're at our final question in this our PEP science session. We're given some information, and this one we need to take it slow so that we can pick up all the points that we need to answer this question. The student is carrying out a fair test, and in that test they want to determine if the length of a nail would affect the pitch of the sound made when it falls to the ground. The student has collected 4 nails and allowed each of them to fall to the ground, and they then recorded the pitch that each nail made. So the question is asking which 2 steps, so we're looking for 2 answers for this question, should be included to make sure that this is a fair test. All right, so notice we're trying to find out, remind ourselves, what is a fair test? Because to answer this question, we must know what a fair test is. Okay, so what's a fair test? All right, so in a fair test, we should ensure that we only change one condition and we keep everything else the same. So let's look at this investigation in a bit more detail. We're looking at the length of a nail, right? We're determining if the length of the nail, right, affects the pitch of the sound. So obviously, if we want to determine how length changes, we have to get nails of 4 different lengths, because that is what we're changing, right? Very good. Now, if it's a fair test, we need to say now, what will we keep the same? So let's see. What would you keep the same? So we're dropping these nails from a particular height, yes? And so if I dropped one from 10 centimeters and one from 50 centimeters, would that be fair? No, it wouldn't be fair. So we need to drop it from the same height. So we have different nails dropped from the same height. And that is what we would ensure is in this particular test. So let's go back to the question. Which 2 steps then should we use to ensure that it's a fair test? Yes? Should we have all nails of the same length? No, but that will not help us to answer if the length affects the pitch. Right. So we need to have the nails of different lengths, yes, and dropped from the same height. And that would be our answer. So I hope you got that answer correct. So I'm sure you would agree that that was quite an intense session, all right? And so we encourage you to continue to practice for your examinations, and good luck.